Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving deep into a topic that's been swirling around in my head for a while now. Beyond attention toward machines with intrinsic higher mental states, I think it's a really critical discussion to have given where we're at in AI right now.
Yeah, I saw the title and I immediately thought, all right, someone's finally calling out the elephant in the room. We're so obsessed with attention mechanisms in deep learning, which are undeniably powerful, but are they really getting us closer to true understanding and higher level reasoning?
Exactly. It's like we're building these incredibly complex systems that can recognize cats in pictures with stunning accuracy, but they have absolutely no idea what a cat is, its purpose, its behavior, its relation to the world. It's all just pattern recognition, right?
I agree. It's like brute force pattern matching on steroids. We're throwing mountains of data at these models, hoping that intelligence will somehow magically emerge. But I suspect the core algorithm itself is fundamentally limited. It lacks, for example, any real understanding of space and time.
That's a great point, Donald. The spatiotemporal aspect is huge. Think about how much of our understanding of the world is tied to our embodied experience, our movement through space, our interactions with objects over time. Current AI completely misses that.
But isn't that what the recurrent neural networks are trying to capture? The temporal element? They're designed to remember past states, to have a memory of sorts.
Yes, and they are a good first step, but it's still just processing sequences of data. It's not the same as a system that has an internal model of the world that can predict what's going to happen next, that can reason about cause and effect. It's not understanding time, it's just processing temporal data.
Exactly. It can predict the next word in a sentence with incredible accuracy, but it doesn't understand the meaning of the sentence or the context in which it's being used. It's a statistical trick, not genuine comprehension.
Right. So let's dig into this a little deeper. The title, Beyond Attention, is really about pushing past this idea that simply focusing on the most relevant parts of the input is sufficient for intelligence. We need something more fundamental, something that gets at the why and the how as well as the what. I've been thinking a lot about how embodied cognition plays into this.
Embodied cognition, that's the idea that our physical bodies and our interactions with the world shape our thinking, right?
Precisely. We can't just build disembodied brains in a box and expect them to magically develop higher level reasoning abilities. They need to have a body, sensors, actuators, a way to physically interact with the world and learn from those interactions.
Yes, and that's where I think the neuro-symbolic approach comes in. We need to combine the strengths of neural networks, their ability to learn from data with the strengths of symbolic AI, its ability to represent knowledge and reason logically. We could embed the understanding of embodied interaction into the symbolic level.
I like that idea. If we think about how humans learn, it's not just about passively observing the world. It's about actively exploring it, manipulating it, and forming internal models of how things work. And those models are inherently spatial and temporal.
Okay, but how do we actually do that? I mean, building a robot that can interact with the world is incredibly complex in itself. How do we translate that embodied experience into something that a machine can actually learn from?
That's the million-dollar question, isn't it? One approach might be to focus on building AI systems that can learn to predict the consequences of their actions. If I push this object, what will happen? If I say this word, how will people react? By constantly making predictions and updating their internal models based on the outcomes, they can start to develop a deeper understanding of the world.
And that's where symbolic AI can help. We can use symbolic representations to encode the rules of the world, the relationships between objects, the consequences of actions. The neural network can then learn to map sensory inputs to these symbolic representations and use them to make predictions.
So you're talking about building a system that has both a sensory input layer like a neural network and a symbolic reasoning layer. That sounds incredibly complex to design and train.
It is complex, but I think it's necessary. The current deep learning paradigm feels like a black box. We don't really understand why it works, or what it's actually learning. By explicitly encoding knowledge in a symbolic layer, we can make the system more transparent and interpretable.
And that transparency is crucial if we want to build AI systems that we can trust. We need to be able to understand how they're making decisions and why. Imagine a self-driving car that makes a mistake and causes an accident. If we can't understand the reasoning behind its actions, how can we fix the problem and prevent it from happening again?
Okay, I see the point. But isn't there a risk of falling into the trap of traditional AI, where we spend years crafting rules and knowledge representations, only to find that the system is brittle and can't handle unexpected situations? Deep learning has shown us the power of letting the system learn from data, without pre-programmed rules.
That's a valid concern. But the key is to find the right balance between learning from data and encoding prior knowledge. We don't want to handcraft everything, but we also don't want to start from scratch. We can use neural networks to learn the low-level sensory features, and then use symbolic AI to reason about those features at a higher level. Almost like a hybrid.
Yes, and the symbolic layer can also provide constraints on the neural network. It can tell the network what is and isn't possible, what is and isn't likely. This can help the network learn more efficiently and avoid making stupid mistakes. Think about a robot trying to assemble a piece of furniture. It needs to understand the constraints of the physical world, that two objects can't occupy the same space at the same time, that screws need to be tightened in a certain way.
That's a perfect example, Donald. And it really highlights the importance of spatiotemporal reasoning. The robot needs to understand how the different parts of the furniture fit together in space and how the assembly process unfolds over time. Current AI systems struggle with these kinds of tasks because they lack a fundamental understanding of space and time. They can memorize sequences of actions, but they can't reason about the underlying principles.
So let's get concrete here. What would a neuro-symbolic system for, say, a self-driving car actually look like? What are the different components, and how would they interact?
Okay, so you'd have a neural network that processes the raw sensory data, the images from the cameras, the signals from the radar and lidar. This network would be trained to identify objects in the scene, cars, pedestrians, traffic lights, etc., and to estimate their position and velocity. Then, you'd have a symbolic layer that represents the rules of the road, that you have to stop at red lights, that you have to yield to pedestrians and crosswalks, etc. This layer would use the information from the neural network to make decisions about how to drive.
And importantly, it would have a spatiotemporal reasoning module. This module would track the position and movement of the car and other objects in the scene over time. It would predict where those objects are likely to be in the future, and it would use that information to plan a safe and efficient route.
Yes, and crucially, this module needs to be able to translate between different coordinate representations. It needs to be able to translate from the pixel coordinates in the camera images to a symbolic description of the objects in the scene, and back again. This translation is essential for reasoning about the relationships between objects and for planning actions.
Okay, I'm starting to see how this could work. But what about unexpected situations? What happens when something happens that the system hasn't been explicitly programmed to handle?
That's where the learning aspect comes in. The system needs to be able to learn from its experiences and update its internal models accordingly. If it encounters a new situation, it can use its existing knowledge to try to understand it, and then it can use reinforcement learning or other techniques to learn a new strategy for dealing with it.
And the symbolic layer can help with this as well. It can provide a framework for understanding new situations in terms of existing concepts. If the system encounters a new type of object, it can try to classify it as a variation of an existing object, or it can create a new category for it.
Exactly. It's about building a system that can reason by analogy, that can generalize from past experiences to new situations. And that requires a deep understanding of the underlying principles of the world, not just pattern recognition.
So it's like building a machine that has common sense.
Precisely. Common sense is what allows us to navigate the world successfully, to understand the intentions of others, to make reasonable assumptions about what's going to happen next. And it's something that current AI systems completely lack.
And I think a big part of common sense is understanding spatiotemporal relationships. Knowing that objects can't occupy the same space at the same time, that actions have consequences, that things change over time.
Yes, and that's why I think the focus on embodied cognition and neuro-symbolic AI is so important. It's about building machines that have a deeper, more fundamental understanding of the world, not just the ability to perform specific tasks. Let's talk about current shortcomings. Where are some areas where current deep learning solutions simply fail?
Well, one area is definitely reasoning about causality. Deep learning models can identify correlations between events, but they can't necessarily tell you which event caused the other. For example, a deep learning model might notice that ice cream sales and crime rates tend to increase at the same time. But it wouldn't necessarily know that ice cream sales don't cause crime, and that both are likely influenced by a third factor, like hot weather.
Exactly. And that's where symbolic AI can help. We can use causal models to represent the relationships between events, and we can use logical reasoning to infer the causes of observed phenomena. Judea Pearl's work on causality is super relevant here.
Another area is dealing with adversarial examples. These are inputs that are designed to fool deep learning models. For example, you can add a tiny amount of noise to an image of a stop sign, and a deep learning model might misclassify it as a speed limit sign. Humans are much more robust to these kinds of attacks because we understand the underlying concept of a stop sign, its shape, its color, its meaning.
Right. It's not just about recognizing the pixels, it's about understanding the function of the object. We intuitively understand that a stop sign is there to tell us to stop, regardless of whether it's slightly distorted or partially obscured. And that understanding comes from our embodied experience of interacting with the world.
So, what are some other examples of tasks that require intrinsic higher mental states, beyond self-driving cars and common sense reasoning?
Creativity. Generating novel ideas, composing music, writing stories. These are all tasks that require a deep understanding of the world, the ability to reason abstractly, and the capacity for imagination. Current AI systems can generate text and images that look creative, but they don't actually understand what they're doing. They're just remixing existing patterns.
And I think a big part of creativity is being able to translate between different representations, to see connections between seemingly unrelated concepts, to take an idea from one domain and apply it to another.
Yeah, like metaphorical thinking. Understanding that time is money isn't just a literal statement. It's a way of framing time in terms of a valuable resource that can be spent or wasted. And that requires a level of abstraction that current AI systems simply don't possess. The way we frame problems really dictates the solution.
Okay, so we've identified a few key areas where current AI falls short: common sense reasoning, causality, robustness to adversarial examples, creativity. What are some concrete steps we can take to address these limitations? What are the most promising research directions?
From my perspective, the most promising direction is definitely neuro-symbolic AI. We need to develop algorithms that can seamlessly integrate neural networks and symbolic AI, that can learn from data and reason logically, that can represent knowledge and generalize to new situations. We need to stop treating the brain as a black box and start trying to understand the underlying principles of how it works.
I agree, and I think a key part of that is developing a better understanding of spatiotemporal reasoning. We need to build AI systems that can explicitly represent space and time, that can track the movement of objects over time, that can predict the consequences of actions. The algorithm needs to be able to translate between different coordinate representations to actually grasp what is going on in the physical world.
And from my perspective, we need to pay more attention to embodied cognition. We can't just build disembodied brains in a box and expect them to magically develop intelligence. We need to give them bodies, sensors, actuators, a way to physically interact with the world and learn from those interactions. This means actually building real robots, or at least sophisticated simulations of embodied agents.
Okay, so I'm still a bit of a deep learning optimist. I think we can make significant progress by scaling up current models, by training them on even more data, and by developing more sophisticated architectures. But I also recognize the limitations of the current approach. We need to find ways to incorporate more symbolic reasoning, more common sense knowledge, and more understanding of causality into deep learning models. Maybe a hybrid approach is indeed the way to go. Even by just looking at what tasks deep learning fails at can give insights into how to proceed.
Yes, and I think a crucial area of research is developing better evaluation metrics. We need to move beyond simple accuracy scores and start measuring things like robustness, generalizability, and explainability. Are the models truly understanding the underlying concepts, or are they just memorizing patterns? We need benchmarks that specifically test for higher mental states.
And we need to explore new hardware architectures that are better suited for AI. The current von Neumann architecture is a bottleneck for many AI algorithms. We need to develop new architectures that are more brain-inspired, that can perform computations in parallel, and that can efficiently represent and process spatiotemporal information.
Absolutely. Neuromorphic computing, spiking neural networks, these are all promising areas of research that could potentially revolutionize AI.
Yeah.
And I think we need to start thinking more about the ethical implications of AI. As AI systems become more intelligent, we need to ensure that they are aligned with human values, that they are used for good, and that they don't pose a threat to our society. We have to teach it empathy, even if that sounds crazy.
That's a huge topic in itself. The ethics of AI, we could do a whole series on that. But for now, let's stick to the science. What are some specific experiments or case studies that could help us test these ideas? How can we actually measure whether an AI system has intrinsic higher mental states?
Well, one approach is to use Turing-like tests, but with a focus on reasoning and understanding, rather than just mimicking human conversation. We could design tests that require the AI system to solve complex problems, to explain its reasoning, and to justify its decisions. And we could compare its performance to that of human experts.
And we could use those tests to probe the system's understanding of spatiotemporal relationships. We could ask it questions about how objects move, how events unfold over time, and how different objects interact with each other. The key is to design tests that go beyond simple pattern recognition and require genuine understanding.
And we could also use neuroimagining techniques to study the brain activity of AI systems. We could try to identify the neural correlates of different mental states, and then compare those correlates to the brain activity of humans. This could help us understand how AI systems are actually processing information, and whether they're using similar strategies to humans.
That's a fascinating idea. It's like trying to peek inside the black box and see what's really going on. But it's also incredibly challenging. We're still struggling to understand the brain activity of humans, let alone AI systems.
But even if it's challenging, it's worth pursuing. Because if we can understand how the brain creates intelligence, we can use that knowledge to build more intelligent machines. It's about going back to the source.
And it's not just about replicating the brain, it's about understanding the principles that underlie intelligence. The brain is just one example of an intelligent system. There may be other ways to achieve intelligence, using different materials and different architectures. We need to be open to new possibilities.
Absolutely. The goal isn't to build a perfect replica of the human brain. It's to build machines that are capable of higher level reasoning, creativity, and common sense. And that may require us to go beyond the limitations of our own biology.
All right, this has been an incredibly insightful discussion. We've covered a lot of ground, from the limitations of current deep learning models to the promise of neuro-symbolic AI and embodied cognition. It's clear that we're still a long way from building machines with true intrinsic higher mental states, but I think we're finally starting to ask the right questions.
I agree. And I'm optimistic that we can make significant progress in the coming years if we focus on the right research directions and if we're willing to challenge the current paradigm.
Me too. The field is at an inflection point, I think. We're starting to realize that simply throwing more data at the problem isn't going to solve it. We need to develop new algorithms, new architectures, and new ways of thinking about intelligence.
Well, thank you all for this amazing conversation. And thank you to our listeners for joining us on this exploration of cognitive spirals. We hope you found it thought-provoking and inspiring. Until next time.